The overall goal of this procedure is to prepare quality iron-rhodium epilayers with a high degree of B2 chemical ordering in order to gain control of the iron-rhodium magnetostructural properties. This is accomplished by first preparing clean single-crystal substrates, properly installing the iron-rhodium target, and annealing the samples overnight under vacuum. The second step is to deposit the iron-rhodium layer while flowing liquid nitrogen through the Meissner trap. The final step is to further anneal the iron-rhodium layers to improve the degree of B2 ordering alpha prime phase. Ultimately, iron-rhodium epilayers prepared following this procedure allow studies on magnetic and structural behaviors and can be inserted into more complex heterostructures in order to investigate the influence of structural changes on the magnetic phase transition.
This method can help answer key questions in the field of nanomagnetism, such as the relationships between microstructure and magnetic properties of iron-rhodium and related materials.
The implications of this technique are to extend our understanding of the remarkable magnetostructural phase transition in iron-rhodium. This is because the causal links between the changes in electronic, magnetic and crystallographic properties as the material undergoes its transition are not yet known.
Visual demonstration of this method is important as there are several aspects of the sputter growth that depart from standard sputtering technique, and all aspects are important to success.
Although this technique is excellent for preparing B2-ordered iron-rhodium epilayers of very high quality, it's also very useful for other ordered alloy materials such as L10 iron platinum or iron palladium.